Good morning, students. I am Dr. Eustace Russell, working as an assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. Today, I am going to teach about the subject called Kinematics and Dynamics of Machinery. The subject code is MR3451. This subject is coming under the semester of 4th semester under the regulation of 2021. This slide represents a glimpse of a syllabus the students are going to study. Unit 1 represents kinematic of machines. They will study about the terminology and definitions and various kinematic inventions and velocity and acceleration polygons, and followed by cams, cam profile, everything they will study in Unit 1. And Unit 2 gives about the gears and gear trains. Here they will study about the spur gear and the involute gearing and the law of gearing, and followed by gear tooth action, interference and undercutting. Unit 3 represents the friction. This they might have studied in engineering mechanics, the friction about, and in this also they will study the friction, how it will be having a very much impact in threads, and frictional drives, as well as belt and rope drives. Unit 4 and Unit 5, that is totally differ from Unit 1 to Unit 3. This Unit 4 represents the force analysis. In this they will study about the D elements principle, followed by free body diagrams, as well as static equilibrium conditions, that is 2, 3 and 4 members, and dynamic force analysis also they will study, followed by inertia forces and torque. And Unit 5 gives the balancing and vibration. In this they will study about the various balancing of revolving masses and reciprocating masses, and equations of motion in concept, damped vibration, and critical speed of the cymbal shaft also they will study in the Unit 5. The main objective of this course is to understand the basic concepts and components and layout of the linkages. As well as they will study the concepts of tooth gearing and kinematics of gear trains. And the concept of friction and various principles of force analysis also they will study. And to learn about the basic concept of static and dynamic balancing and vibration. So at the end of this course, the student will learn about the basic terminologies of kinematics and dynamics of machines. They will study the concepts of kinematics and dynamics, including forces and vibrations. The student can be able to study the various parameters of mechanisms, gear and gear trains, and they can learn to apply the mechanisms for various design of new machines. And they can analyze the working of various mechanisms also, such as gear and gear train. In this, we will study about the topic called CAM. Before that, I want to tell about the kinematics. What is kinematics means? This definition already you might have studied in engineering mechanics course. That is nothing but study of motion of cam follower without considering the forces acting on it. What are the forces we'll be considering on that? We will not consider that. That is called as nothing but kinematics. Kinetics is nothing but you have to consider the forces that is acting over on that. That is totally different. So in this we can see one video. It is shown in this slide. It represents how the closing and opening of valve that will be happening in the automobile engine. You can see it here. That is the green color one in the top. That is a cam that is rotating over there, and followed by it is controlling the opening and closing of the valves. We can see here clearly. This slide gives a basic concept about the classification of followers. Based on the surface of contact, the follower can be divided as the various categories, that is knife edge follower, roller and flat face follower, spherical faced follower. In upcoming slides, you will see about the various follower with the symbol sketches and diagrams. That is very easy to understand about this. Then according to the motion, that is a reciprocating one and oscillating one. According to the path of motion, we can categorize into two things, that is a radial follower and offset follower. And various motion of follower, that is uniform velocity, simple harmonic motion, and uniform acceleration and retardation. Now, as I already told, the various classifications, the knife edge follower we can see in the picture in the left hand side, we can see we have a point contact in that, point of contact. In this, the wear will be more. At the same time, in the right hand side, we can see about the roller follower. In this, we have a roller in contact with the cam surface that totally reduces the friction. When compared with the first category, this reduces the friction that leads to less wear and longer service life. The next one is nothing but flat face. Flat face is nothing but we have a larger contact area. We have a larger contact area that is followed by it reduces the wear. And spherical is nothing but we will get a uniform distribution of contact pressure between the follower and the cam. It is followed by in reduced wear and improving in performance. We can see in the sketch clearly that is a spherical one. Then according to the motion of the follower, we can simply categorize into two things, that is reciprocating and oscillating. Reciprocating in sense in the left hand side, we can easily see this diagram. In this, while moving, the follower reciprocates, that is up and down motion you will get it. Oscillating is nothing but just like a pendulum one. It is oscillating up and down motion as I shown in the right hand side of this diagram. That is uniform rotary motion of the cam is converted into oscillatory motion of the follower. You can simply understand with corresponding to this diagram. Whenever the cam is rotating, automatically the follower will give oscillating motion. Radial. Radial is nothing but when the motion of the follower is along an axis passing through the center of the cam, it is known as radial follower. That is, we can see in the sketch, the axis of the follower is passing through the axis of the cam. Offset is nothing but we can see the difference in between these two. We can have an offset distance. We have an offset distance that is nothing but follower axis as well as cam axis is have a certain distance that is called offset distance. And according to the follower of motion, we can see here in the left hand side of the first diagram, that is the follower is rising up. There is no double part. Automatically, it is come to the return stroke. That is graph is move in a gradually it is increasing up and gradually it is decreasing down. That is nothing but rise, return, rise. Then the second diagram of the left hand side, we can see dual, rise, return, dual. Then first of all, we have a dual in the lower side. Then gradually it is rising. Then gradually it is returning and followed by dual. As well as to the right hand side of this, we have a dual, rise, dual, return, dual. Whenever the rise portion is completed, we have a dual area, and after that it is come to the return part. So we can see in the problem while solving that the various conditions they will give when you have to follow the dual condition, rise, return, the various angle of rotation they will give in the problem. By that we will do that various conditions in that. So we can see in this problem, we can see one basic problem, that is knife edge type we have took. What are the conditions they have given? The follower type they have given as knife edge one. And lift is nothing but how much the follower has to be lifted. That is 50 mm. It is clearly given in the problem. Then base circle radius. The cam, the middle part is called base circle radius. Outstroke is moving. Outstroke is nothing but that is the returning stroke. For 60 degree, dual for 45, and return with SHM, and followed by dual for the remaining period. The various things they have asked in the problem: maximum velocity, acceleration during outstroke and return stroke. The cam rotates at 1000 rpm in clockwise direction. So this maximum velocity acceleration we can solve using basic formulas. Before that, I want to show about how the displacement diagram is drawn, followed by, without drawing the displacement diagram, we can't draw the cam profile. First of all, we must know how to draw the displacement diagram. Actually, it is clearly given. It is SHM motion. That is simple harmonic motion will be followed in this diagram. The question itself it is given. So what is given here? The outstroke, some angle that is given. We have to convert that into scale. In centimeter, we have to convert into the scale, and you have to divide into 6 equal parts, and followed by dual area, and followed by return stroke. For getting a clear curve, we have to divide into 6 equal parts. We can divide into some more equal parts also, but our easy understanding, we can go with 6 equal parts. So after dividing with 6 equal parts, what is the height of the diagram in this means 50. That is the lift of the stroke. It is given in the question. Now in the left hand side, how the cam profile we are getting means we have to fix the angle first. What are the angles you have to fix? The first angle is 60 degree. It is given. You have to take it in protractor with reference to the vertical line, then followed by 45 degree, then again followed by 90 degree. We have to take the remaining angle should be keep as a dual condition. It is given in the problem. Then what you have to do in this? You have to divide that angle into 6 equal parts. We have to divide into 6 equal parts. We should not divide the dual area into various parts. There is no need to divide the dual area. Only we have to divide the return stroke and the out stroke. The first quadrant of that angle, we have to divide it into 6 equal parts. Then we have to divide the 90 also in 6 equal parts. Then with the help of the compass, we have to take all the distances from the displacement diagram only. That's why I already told. Without displacement diagram, it's very difficult to draw the cam profile. From using compass, you have to take the distance. For example, you have to take the left hand side of the outstroke. What you have to take means 1 to A. We have to take it in compass and keep in the center point 1 in the cam profile and take on intersection. Then followed by 2 to B, 3 to C, 4 to D, 5 to E, 6 to F. Everything we have to take it in compass, and gradually we have to take the intersection curve arc in the cam profile. Already we marked all the angle, the displacement, the split up of angle already we have noted. In the split up of the angle, we have to take all the distances in this cam profile diagram. Followed by the same thing should be followed in return stroke also. Take the intersection in the corresponding angle, split up of the angle. Then finally, you will get a cam profile diagram with the help of the, we have to use a freehand sketch only. We should not join it with the scale. Just you have to use this pencil and take a fine path, joining all the points. It will clearly give a cam profile. Then finally, you have to dot the curve, followed by the cam radius. That is the circular one. That is already took us 50 mm. Then the next problem represents about the roller follower. The last problem we have seen about the knife edge follower. In this, we are going to see about the roller follower. This roller follower also they have given some dimensions, basic specific dimension, that is base circle radius, roller radius. Here outstroke is given as uniform acceleration and retardation. That is totally different method. The last problem we have seen about a simple harmonic motion, SSM. This is totally different. In this also various angle they have given 120 dual, as well as return is followed by 90 degree. The speed is given as 1200 rpm, that is given in clockwise direction. When you are getting a speed, when the problem if they are giving speed means automatically we can find out angular velocity. Angular velocity formula, what is angular velocity formula? Basically everybody knows that omega is equal to 2 pi n by 60. We can get the value as 125.71 radian per second. Then maximum velocity during outstroke. This having a basic formula, that is 2 times of stroke divided by outstroke time. That will be again converted into terms of angle that will be converted into radians, that is 2 pi by 3. Finally, you are getting as approximately 3 meter per second. Same formula followed for return stroke also, same formula. Instead of that, we have to look on to the angle, that is the denominator. We have to check what is the angle it is given. it is 90. The various angle position, we have to change it. The remaining formula as it is. Then acceleration of the follower during outstroke, that is VO divided by T naught divided by 2. We are getting the answer T359 meter per second square. And similarly, acceleration of the follower during return stroke, we are getting 639.956 meter per second square, followed by the formula 4 pi square S divided by theta r square. Then we have already seen the displacement diagram of SHM. This is the displacement diagram for uniform acceleration and retardation. In this, one difference we can see in this, in the left hand side, there is no need to draw a semicircle. Only for the simple harmonic motion, this semicircle is needed to complete the displacement diagram. In this, there is no need for semicircle. Simply we have to divide the various segments into 6 equal parts, 0 to 6, then followed by dual and return stroke and dual. Outstroke, it is angle, it is already given in the problem, 120, dual 60, then 90. 120, how we will divide? 20 degree, 2 into, that is 6 into 20, you will get 120 degree. Dual, there is no need to split up the angles, you have to keep as it is. Then return stroke, what is the angle? 90 degree. Again, it is divided into 6 equal parts. Then you will get the displacement diagram. Then followed by, we have to draw the cam profile. In this, one difference you can see, and compared with the last diagram, that is simple harmonic motion, knife edge follower, there is only one circle will come, that is the base circle of the cam. In this, another one circle also we are going to draw, that is prime circle. Only for the roller follower, you have to follow the 2 circles. One is the base circle of the cam, another one is prime circle. When you are drawing the radius of the cam, roller cam, that is roller follower, the small circle should touch the base circle. That is important. We can see the first circle starting with 0, that is touching with the base circle, and the end circle also should touch with the base circle. Then the followed by divide into equal parts, 120 degree. We have to take it as 6 equal segments, means 20 degree we have to take. There is no need to divide the dual area, that is 60 degree, keep as it is. Then 90 degree also, again we have to divide into 6 equal parts. Then with the help of the compass, measure the distances from the displacement diagram and take the intersection arc in the cam profile. Finally, you will get a cam profile joining the circle lower end, starting with 0. With the help of the curve, you have to join with the base circle. The curve should not enter into the circle. That is important. That is one important point we have to consider. Then you will get the final curve. Again, offset method. This we have seen already in the various types of follower. That is radial offset follower. In this, we have a distance that will be given in this type of problem. In this, what is the distance it is given? Means it is a 5 mm. 5 mm distance should be maintained. It is clearly given. That is follower, a line of action as the center of the cam will follow some distance that is called 5 mm. Then again, with the help of scale and pencil, we have to draw the tangent lines to the center of the circle. So that is offset circle. We have to draw the tangent lines. Previous type, first case, there is no need to draw the tangent lines because there is no offset condition. In this offset condition means you have to draw the tangent lines, and the same procedure will be followed. We have to take the distance from the displacement diagram and take the intersection arc, and finally join all the points followed with the help of the pencil and joining with the base of the circle. The curve should not enter into the circle. That is important. Finally, you will get the cam profile. So today we have seen about the basic concepts of cam and the various classifications also we have seen, and the basic definitions also we have learned, and followed by 2 problems also I have taught in this video. Kindly go through the various types of the follower, as well as simple harmonic motion problem, as well as uniform velocity and acceleration type of problem. This type of problem is very, very important, and most of the question papers, this type of method they have asked in the part B questions. So kindly go through it. Again, we will see in the upcoming videos with other units. Okay, students, thank you. Thank you all.